question number 4 pula. This is a past year question. So for my class, we've discussed this before this tutorial questions came out. So this is basically just a repetitive, so I'm just basically repeating this to you lah. Okay, so this is a long metal bar. Okay, so the long metal bar has a length of 0.6 meter pulled to the right. So this is the direction of V lah, at a steady speed of 5.7 perpendicular to a uniform magnetic field. The metal rails are connected to a 5 ohm resistor. Calculate the magnitude of the EMF induced in the circuit. Again, whenever they ask for induced EMF and you have velocity, we are going to use this equation here. So we have B, we have L, we have V. Now, what is the angle between B and V? So sekarang the question actually mentioned the angle. Dia cakap di sini, the long metal bar being pulled to the right at a steady speed of 5.7 meter per second perpendicular to a uniform magnetic field. So perpendicular means the angle between these two is 90 degree lah. So dapat sudah semua information that is needed. 0.7, 0.6, V is 5.7 sine 90 degree. Okay, so sekarang ni kamu just perlu substitute dan substitute in your calculator lah. Just calculate it, solve it, you will get 2.39 volt. Okay, right, next you have to calculate the current through the resistor and its direction in the metal bar. So basically EMF equal to IR. You just have to apply the Ohm's law. So this is gonna be I equal to EMF over R, which is 0.479 ampere lah. So make sure in exam you will you will write the substitution lah supaya kamu dapat marka. Okay, so dapatlah this answer here. So how do we determine the direction? This is there are 3 variables that you are gonna look at, which is the BVN, BVNL. Wait, let me just check. Oh no, this the velocity BN, the direction of current lah dia akan bagi tahu. So for this case, you can either use the Fleming right hand rule, if I'm not mistaken. Let me just double check with my notes. I think it's Fleming left hand rule. Is it? Let me just check my my notes. It's here, left. Oh, sorry, it's Fleming right hand rule. Okay, so we're gonna use Fleming right hand rule, where our thumb is telling us the velocity, this is the magnetic field, and lastly the middle finger is telling us the direction of current lah. So if you are gonna do this, do it with your right hand and do the Fleming right hand rule, and it should tell us that the direction of current is downward in the metal bar, or you can just write downward, or I would write it as clockwise lah. If you are confused how do I get it to be clockwise, this is your direction of current. Okay, so this is the direction of current, so it's gonna be passes through this here, so it's gonna be clockwise lah. Okay, so but up to you, you can either write it as clockwise ataupun downwards. Alright, so that is the solution for question number 4.